Hi everyone. So we are going to wrap up chapter 1 in this lesson in 1.6, and we're going to first really talk about the idea of a function. And there are kind of too many definitions of functions, and I'm going to state, we could think of it as a rule that assigns, well, basically what it is, it's a rule that assigns to each input a unique output. So basically, when you think of a function, you want to think of input values and output values, and or you can think of it as a machine or a formula where you plug in one input value and it spits out one output value and only one output value. And that's really the only requirement we're talking about here when we talk about functions. Now, specifically, if one variable is a function of another variable, that just means, in particular, let's say if x and y are variables, and we say y is a function of x, that means there's at most one value of y for each value of x. So if you plug in a value of x, you might get an output or you might not, but you'll never get two outputs or three outputs. Okay. So what that means here, for example, in this first example, if we say if these are the x values and the y values, because we get two output values for one, right? And we have 1 gives us 5, but 1 also gives us 6. So in this case, this is not a function. Okay. Or I should say x is not a function, or y is not a function of x. Okay. Here, if we go look here, 0 is the input is 0, the output is 5, the input is 1, the output is 6, the input is 2, the output is also 6. That's fine, because the output you can have, the outputs might be the same, but the inputs have to be different. Okay, so and 3 goes to 7 and 4 goes to 8. So this would be a function. So y would be a function of x. Okay, and over here we can also see that there's exactly one y value for each of these x values, right? So once again, this y is a function of x. Okay. Now, graphically, it's kind of easy to see if something is if y is a function of x, because so all of these pairs correspond to points on the xy plane. Okay, so those points will form a graph or a curve, or something like that. And we want to see to determine if y is a function of x, we look at the corresponding graph and see if it passes what we call the vertical line test. And what that means is that any vertical line intersects the graph at most once. It might not intersect it at all, but it can't intersect it twice or more than once. Okay, so for example, this would be this certainly passes the vertical line test. Okay, if you draw any vertical line, it crosses exactly at either exactly once or not at all if you draw it over here. So this would be a function. Okay, same thing over here. Okay, we see that this is a function. If any vertical line crosses exactly once. However, here we can see this clearly fails the vertical line test, because we can draw this vertical line and we get 2 points. And what that means is these points have the same x value but different y values. Okay, so that would mean if x is the input value, we have two different output values for this input value. So that's why this is not a function. And then also you can see with a horizontal line, you can see that any vertical line intersects it exactly once. So this would be a function. Okay. And just so you, to make it clear, a vertical line, if we have if we just have a vertical line by itself, that certainly is not a function because, you know, if you take the vertical, this vertical line, actually we'll have many points with the same x coordinate but different y coordinates. So this would not be a function, or at least y would not be a function of x. Okay, then one other thing here we might want to say is that we can talk about something called linear functions. We'll say if you have something like y equals negative 7x plus 15, let's say, that should be pretty clear that that is a function, because you could graph this. This is going to be a line with slope negative 7 and y-intercept 15. So you could graph it, but I won't be that. It would look something like this, okay? So that would also pass the vertical line test. And in fact, any line that's not vertical will pass the vertical line test, and that's why any linear function will, or any linear expression like this, y equals something times x plus something else, that's always going to be a function. Y will be a function of x. Okay. Then the other thing I just want to talk about is the domain of a function. And the domain is the set of all possible values of x, or more generally, all possible inputs. Okay. Graphically, what this means is that the domain corresponds to all the x coordinates of a certain graph. Okay. Okay. And so if, for example, if 5 is in the domain, then there must be some point on the graph whose x coordinate is 5. That's all it is. And with the domain, we don't care about the y coordinates, we just care about the x coordinates. That's the domain. So over here, we can see that in this graph, first of all, this is a function. Y is a function of x because it passes the vertical line test. But we can see that any x value between negative 3 and 4 is going to corresponds to a point on the graph. So in this case, the domain would be all x values between negative 3 and 4. Okay, and that would be the domain of that function. Again, the y we don't care about the y values when we're talking about the domain. Here for part B, this is a line that goes on forever. So, so theoretically, you could take any point, and pick any x value, and there's going to be a point. So if x is 100, there would be some point up here on this line, and if x was like negative, 50, you'd have a point on the line down here. So in this case, the domain would be all x values, so we can just say all real numbers. Or we can just say all real numbers x if you want. Here we can see this is a function. The x values are the x coordinates of the points are all greater than or equal to 5. So here the domain would be all x values greater than or equal to negative 5. And here we can see that because this curve just goes on forever, we can pick any x value here, and there would be a point on this curve. They might have to go up here somewhere. So the domain would again be all real numbers. Okay. Another way of thinking about the domain would be if let's say 4 is in the domain, then the vertical line at x equals 4 would have to cross the curve at some point. So let's say if here's 4, and have this vertical line here, it would have to intersect that at one point to be in the domain. Okay, if this vertical line does not intersect the graph, then it's not in the domain. All right. So that's what the domains are, and we'll say probably a little bit more about domains later on. So take care. See you next time.